All right, this video is going to talk about how to actually graph various sine and cosine functions. Again, we're not going to deal with any shifting left and right or shifting up and down. Today we're just going to talk about stretching or dilating your periodic function here, whether that means vertically changing the amplitude, as we call it, or horizontally changing the sort of period, if you will. Again, this is the video 2 of 2 videos. So again, this one's going to actually talk about how do we actually graph these functions. The other video talked about the fine-tuned details. So let's just remember a couple of those details. When we're talking about graphing a sine, such as what we have on the graph or on the screen here, y equals the sine of x. Remember that the sine of x typically starts at 0, 0. And because we didn't put anything in front or inside of, right, it's just a basic sine of x, in front there would be a 1, which means our amplitude equals 1. And because inside that's a 1 as well, again, our period would equal 2 pi. Right? Normally we'd say 2 pi divided by b. Again, if we write a basic function that when we talk about a and b, a would be something multiplied in front, b would be something multiplied inside of our sine. For us, again, both of those values were 1s. Right? So again, we're going to start at 0, 0. We're going to go 2 pi down the road. So I'm going to go 4 tick marks. It's always a good idea from where we start. I'm going to go 1, 2, 3, 4 tick marks. And I'm going to call that 2 pi. That's going to be 1 full period of my graph. So again, if I wanted to do 2 periods, now the directions only say 1. But if I did want to do another one, I'd go another 4 tick marks. And I'm going to call that 4 pi. Maybe we'll take advantage of that here in just a second. But again, to get 1 full period of our graph, we want to remember that we start and stop in the same place, right on the x-axis. Halfway in between, we're still going to be on the x-axis. And then in between those numbers, again, if we're thinking about our unit circle, those are the points where we would be on the x-axis, but halfway in between going around a circle, again, at 90 degrees or at pi over 2, right? At pi over 2, we would be up 1 unit, and at 3 pi over 2, we would have been down 1 unit. And so we get that simple sine graph. Let's see how smooth I can draw this on the computer here. Looking like that. Again, that's 1 phase or 1 period of, right? 1 phase or 1 period of our graph. Again, if we wanted to draw more than that, we could just repeat our pattern. Again, we're going to go 1 pi and 2 pi down the road. We're going to max out in between the first 2 points, and we're going to minimize between the next 2 points. And again, all we would have to do is repeat our curve then. And again, the more you practice those curves, the better and better they'll look. So don't worry if yours doesn't look perfect the first few times. Mine don't always look perfect either. But again, there's a graph there. Or we could have backed up. Again, we could draw all the phases that we want here. Again, I would go negatively first, then positively. So again, we want to go down here, up there. We do want to include just an arrow on each end, just reminding ourselves that these do continue. These do continue to keep going, right? Now, let's take a look at a couple of different changes here. If we're multiplying in front by a 3, again, that means that our a value, as we would often say, is a 3, or basically it changes our amplitude to the absolute value of 3, or basically 3 there. Well, what's going to happen is we're going to stretch our heights then, right? That's a vertical stretch by 3. So instead of 1, we're going to max out at 3 up here. But again, we're going to still start at 0, 0. Again, multiplying by 3 doesn't change the number 0, right? It wouldn't change all those points that are on the x-axis. But what it does is take our maximum up to 3 and our minimum down to negative 3 down here. So that one's going to drop there over at 3 pi over 2. We're going to be down at negative 3. So our graph's going to be a little bit taller, right? Both positively and negatively before it keeps on traveling, right? Again, if we only go 1 phase this time before it keeps on traveling, again, it would just repeat that same thing above and below the blue line as well. Down at the bottom, you'll notice we're multiplying inside by 2. Again, remember that's our b value inside of our basic formula. So again, what's going to happen is the period is going to change this time. remember that the period is 2 pi divided by b. So 2 pi over 2 is really just pi. Again, if we start at 0, 0, I'm going to make 4 tick marks. Notice they weren't drawn for me, so I'm going to draw them myself. Call that 2 pi. But again, I'm not actually going to call that 2. That was a bad idea. Remember, if the period's only pi this time, well, why not stretch our graph a little bit? Let's call that pi. Halfway is going to be pi over 2. And again, at both of those points, we're going to still be on the x-axis this time. At pi over 4, okay, we're going to be up at our maximum. And now notice we were a 1 in front. So therefore, we're going to max out at 1 up top. And we're going to minimize down here at -1, down below. And again, our graph then is going to curve up and down. It's going to basically look just like it did up top, only now notice again, we changed our period, right? We changed those x values. Technically a much shorter graph, right? If we did that same graph up top, it would have done its full curve up, down, and back again, right? Up, down, and back up top there. Half the time that it took that orange line, right? Half the time that it took the red line, it would have done it right away. Now I'm going to take that off of that graph because that looks pretty bad. But again, it's half the width because the period was only half of what it was previously. Do your best to draw these as smoothly as possible. Again, we're going to put a couple arrows on there. But again, that's one decent looking phase shift, or not, sorry, phase shift, but period change, right, of our graph. And what I always want to encourage you to do is draw these as swan-like as possible. As swan-like makes you, when you say the word swan, makes you think just a nice smooth line, right? As swan-like as possible here. Let's take a look at a couple of cosines very quickly and see if we can't get these done in just a little quicker fashion than we did the sines. Again, you'll notice 1 in front, 1 inside. So when we're identifying our amplitude, it's going to be 1. Period's going to be 2 pi. Only difference is, remember that the cosine starts up at 0, 1. So we're going to start up here, right, at 1. I'm going to give that a little bit of space just looking at my next graph. Well, that'll make more sense in a minute. But I'm going to start with this being 1. I'm going to draw 4 tick marks. And again, at the 4th one, I'm back up to 1. Halfway in between, we would be down here at -1. And again, in between those, be right on the equilibrium, right on that middle line. Sometimes I call that the equilibrium, so that you can sort of curve down to our middle point, to that bottom half of the graph, and then curve back up top. Now remember, that's a maximum, so don't let your arrow go up from there. You got to come back down again at that point, right? Same thing on the other side. Then you get that swan-like idea, right? Now notice in the next one, A is a -2. Well, that makes our amplitude equal to the absolute value of -2, right? Or basically 2. So again, we're going to start 2 units high instead of 1 unit high. But because it was also a negative here, that's a vertical reflection. So let's start at the point 0, -2. We're going to start at the minimum. Again, 4 tick marks away, or basically at 2 pi. Right, we're going to be at the minimum again. Halfway in between, we would be up at a maximum of +2. And again, halfway in between, we're going to be at equilibrium. So again, if we draw that curve up top, didn't quite center it, but that's okay. Just make sure we can visibly see those points. There's going to be our sort of swan-like curve there, right? Again, amplitude of 2, total height of 4. Again, starting at a minimum because of that negative value. Finally, let's do the one down here at the bottom. Again, we'll notice that A is a half, which again makes for an amplitude of a half. B, on the other hand, is a 1/4. And remember that the period equals 2 pi divided by B. Or basically, if you multiply by the reciprocal, our period's going to be 8 pi this time. So again, I'm going to make 4 tick marks. And this is going to be 8 pi out here at the right. Cosine, again, starts at its maximum. And now you'll notice, again, the A value was only a half. So we're going to start up at a half this time. We're going to finish at a half out at 8 pi. Over here at 4 pi, we're going to be down at negative a half. But again, according to my labels, that's my first tick mark there. Halfway in between, we're on equilibrium. And again, then we can draw our curve. As long as we know the period and the amplitude, we can make that graph labeled correctly. I hope that helps you graphing sines and cosines. If you have any questions, talk to your teacher. Otherwise, have a great day.